maybe that's gonna work. Let us go to record the seminar for tomorrow. We're gonna see this. We are using, which actually a tool that's called KiCAD. KiCAD is an open source EDA software that you can use to create PCBs. Basically consists of this. This is the main panel that you have once you open KiCAD your first time, and it has those different tools. So we are going to be exploring some of them and try to design a very simple design of a PCB. So the first thing that we have to make once we go inside is to create a new project. In this case, I'm gonna create a project here. I'm gonna place better maybe here in lab stuff. I'm gonna create a new folder with new projects called test. It's gonna be called test, and the project's gonna be test. It's fine. So now we can see that there is two main files here, the PCB and the schematic. One is the electronic schematic, and another is the physical PCB. And basically in KiCad, you have to go by those steps. It's pretty easy. So the first thing that we have to make is to create our own schematic. Once we go into the schematic, we can add different stuff. First thing that we have to add is we go here and this symbol that says add symbol, and that's gonna give us access for our symbols library. So I press here, I press the symbol, and it's going to open, I hope. Yeah, there it is, the symbols library. And here there are different components. We can also add some, but just for this case, I'm gonna use a LED. For example, here it is an LED. There it is. If I press the KR, I can rotate to different places. Yeah, so I'm gonna add a LED. If I press, for example, the letter R, I'm gonna find the resistor. A resistor. Also, I am able to find connectors. Gonna use two connectors by pin here. So connectors, yeah, there it is. And once we have, so this is gonna be a very simple circuit. It's gonna have a voltage source going through the LED, then to the resistor, and then come back to the ground. So I just need to connect this. One thing that will make this is by doing this. Yeah, and I'm gonna add the resistor. Other thing that I can make, and actually is better for long circuits, is to add labels. So for example, I'm gonna add the label GNT, GNT, and I'm gonna place the label there. And here I'm gonna create another label called GND. There it is. So now has the same that create a wire. Basically, when I create my projects, usually I use labels because it's easier to change connections, unless the circuit was very simple, like this. So we are going to try um, to make this circuit physically. So once we have this, we have to create something that's called the netlist, which should be by here. Let's see if I press there, I can go. Yeah, let me open this stuff, but it's not like when I go. So now that this is the one, this we press the annotate, so it's gonna add some element for all the systems. And the other stuff that we need to make after that is to create the root assignment tool. So now I have to create the footprints from the schematic design. So usually I think that LED is a diode, so maybe it can be here. So there's several diodes. Or I can look here, just place LED, LED, and see what's I have when I press LED. Mm, no, there's nothing there. So let's see, general maybe, symbol, no. So here I have several stuff. Mm, yeah, here it is. For example, LEDs. And here we have the different LEDs connected. I can see also explore the footprint. For example, this is an LED horizontal that I can place, for example, this is in a vertical one. I'm gonna use in this case a classical 5 millimeters standard 5 millimeters, which is this one. And I'm gonna place there. I press just and it's assigned. For the connector, I think it's gonna use a connector, use connectors, length of connectors, a pin connector. So, for example, you can see here how it works. One pin connector. Let's see. No, actually, it's not pin connector. We have to use another one. Pin header. Pin header 2 mils, I think. Not 2.4. I'm gonna use this one. Pin header. Because here we have several. For example, this one. This horizontal. We can also place vertical. There it is. So I'm gonna place vertical. And for the resistor, I think we have resistors here. Resistor through hole. I'm gonna use maybe it's no, maybe this one. No, no. Here's vertical or horizontal. I can use this one. This is horizontal, for example, to assign the dot. So now I press OK. I have to apply schematic and continue. OK. And I think that now I'm able to go here. So once I'm here, I have to import. And I update this. Now I have my parts here in the physical elements. So now I can work here. So with the letter M, I can move the elements. With the letter R, I can rotate. Yeah, I'm gonna make a very compact circuit. Usually you can place as near as you need it. M. And it's gonna tell you what are the needs you need to have. So for example, here it's gonna be better. Get something like this. I also can move this part, for example, the R1 stuff, letter M, and place here, for example, instead. Other side. Now I can go here to create the connections, and also can. I think I can. I will be able to see these connections. Well, if needed. So now I create that same code. I can go to the bottom also if I need to layer stuff. And now I need a ground. Yeah. The ground, the ground, the ground. Yeah, okay. But I'm not gonna place the ground because also I have to create the boundary conditions for this one. And for that, when I press that stuff, I go to the edge cuts layer. Go to the edge cuts layer and also can make it this size again. For example, go to 1 millimeter resolution. We can create the cuts for the PCB. And also I can create something that's called the rule area. So it's going to be placed in both sides. It's going to create a plane. Yeah, I create a plane. Zones. Yeah, make a mistake here. So put it again this one. Yeah, and the area names can be G and D, for example. So now it's there, and I'm gonna fill it. Zones with all areas. What's going? Yeah, with a rule area. That's yeah, here it is. So it's not an edge cuts. Should be non-copper. Mm, mm, okay. If I place here, yeah, that's the stuff. Have to be placed in the right layer. There it is. Now I fill the area and I have my ground connection. So the last thing that we have to make is to analyze that the circuit was right. Let's see. We run the DCR and it says that the references are outside the page, so they can move them. Let's place one here. We'll place the other one. That's not again. I'm gonna place the J1 elsewhere. Place here, for example. You run again the DCR, and now it's clean. So now I have created a very simple PCB.